Maybe you can find an investment that ought to return that much, and maybe you can't. Now, though, you're in a much better position to take whatever action you need to make your dream come true, whether that's giving up the whole thing as a bad job, or whether it's skipping your vacation this year because you're saving to make a lifetime dream come true. Instead of nailing down the time and the size of the investment, let's nail down the rate of return in the investment. What happens? Say you can only earn 9% instead of 11.3%, but you have $2,500 to set aside now instead of just $2,000. How long will you have to let this investment ride before you have your $10,000? The formula tells us that an investment of $2,500 times 1.09 raised to some unknown power equals $10,000. Turns out you'll have to wait just over 16 years to take your dream vacation in this case. The larger investment almost, but not quite, offsets the lower return you expect to earn in this case. Now let's say that your dream vacation has to occur at a certain time. Maybe you're an astronomy buff and want to be at a particular place on a particular date and time to view a solar eclipse. That eclipse is 12 and a half years from now, and you can only earn 6.5%. How much do you have to pony up now to make it happen? Don't let the fraction and decimal points scare you. Your calculator will be just as happy to solve this one as it is for round numbers. The formula says that some unknown investment multiplied by 1.065 raised to the power of 12.5 equals $10,000. I don't think you're going to like the answer to this one, though. After all, we already know from the previous two examples that rates of return well above 6.5% and investments of $2,000 or even $2,500 would leave you short of your goal in 12 and a half years. Hate to break it to you, but how does an investment now of $4,551.24 sound? Of course, you might want to make repeated payments instead of just one initial payment. That would be what's called an annuity. You may have heard the word annuity used to describe an investment that converts an initial outflow into a series of payments you receive over time. Here, it's that concept turned inside out. A series of outflows builds to a terminal value you receive at the end. The formula for computing annuity values is more complicated than the one we've been using, but the idea is the same and the results look much the same too. I promised that I'd only use one formula, and I'll stick to that, so I won't give you the annuity formula here. You can find it on the internet if you like. In fact, there are lots of tutorials on the internet if you're interested in the underlying calculations. We won't take the time to go into that. You just need to know that the key points of annuities and single investments are the same. The same three variables affect the terminal value: the size of the investments, the rate of the return, and the time horizon. The biggest difference between an annuity with its multiple payments and a single investment is that the terminal value builds much more rapidly with an annuity. That makes sense because making more investments as time goes on puts more money to work for you. Let's see how making annual payments affects the way you save for that dream vacation. We still need to nail down two of the variables in the formula. We'll do time and investment. I've already decided that you can defer gratification for 15 years. But instead of asking, how much can you invest right now, we'll ask, how much can you invest every year starting now? Let's say it's $250. If you can invest $250 every year and need $10,000 for a dream vacation in 15 years, then it turns out that you need to earn just over 11.5% annually, which isn't far from the 11.3% we got with the one-time investment of $2,000. To me, the smaller annual payments seem much easier to handle. $250 per year sounds much less intimidating than investing $2,000 now. At a rate of around 11.3 or 11.5%, you can reach your goal